right, so for 9-3, we're taking a new direction, you could say. We've been looking at simplifying rational expressions. What we're going to take a look at is a little bit of graphing. Here is the parent graph. We've talked about parent graphs all year, and then we're going to be shifting it, flipping it, and it follows, again, all the same rules that we have established for the entire year. So this is the parent graph, so I'll give you some time to get a quick sketch of it. There are two asymptotes on this graph. They're right on the axes, the x-axis and the y-axis. This is the function right here. Y equals 1 over x. And it creates these two curves, two red curves that I have up there. Now the graph is going to move around, and those asymptotes are going to move with it. Here is kind of the formula that we're going to be looking at. Just like this note says right here, there's going to be a number up here. For this year, we're just going to ignore that. In future math classes, depending on what math class you take, you may look into that a little bit more in the specific ways that it changes the graph. But it is the steepness. But I'm just worried about, can you move the graph around appropriately, and can you flip it if need be? So the value with x, just like it always has all year long, is moving left or right. And the k value is moving up or down. Okay, if you see a negative sign, it's going to flip it. So instead of being in the upper right and the lower left corners, the graph will be in the upper left and the lower right, just be in the other two quadrants. So we're going to try two examples of this, and then you'll have some time for homework. We're also going to state the domain and range for these as well. All right, so here we go. Here's your equation. Y equals 5 over x plus 3 minus 2. Get a graph ready. We're going to figure out where this is moving. So again, it's always the opposite, the value with the x of the direction you feel it should go. So instead of going right, this is moving left, and this is moving down. So we're going to move the asymptotes. Okay, that's the easiest way to graph these. So instead of the asymptotes being on the x and y axes, it has to move left 3 and down 2. So those are your new axes in a way. And asymptotes move there. And then all we do is put the curves in the appropriate corners. Now we don't have a negative sign, so they go in the same corners that were on the parent graph. Right there, and right there. So the asymptotes are x equals -3 and y equals -2. So if they ask for the equations of those, they're just asking for the equations of these lines. So this is the equation of this line. That's the equation of that line. And now we just need the domain and range. So remember, the whole purpose of an asymptote and the definition of it is that the graph never ever touches it. It keeps getting closer and closer to it, but it can never cross that line. So looking at domain and range, the domain, remember, is left to right. So if we're scanning left to right, this arrow right here is pointing forever and ever and ever to -infinity. So domain is going to go -infinity up to, it's going to keep traveling, 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 and it's has to stop right here at this asymptote. So it's going to stop at -3. But the graph is going to pick up again at this other curve over on this side. So that one starts at -3, and it goes on forever to infinity. Now remember that when you have two sets for your domain, you want to put a U in there for union to put those together. Capital U. All right, range. This is scanning from bottom to top. So this arrow right here tells us that we're going forever and ever down. So it's starting at -infinity, and it's going to go up, 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 all the way up until it hits the asymptote like a ceiling, which is at -2. And then it's going to pick up again at -2 on the other curve and go all the way up to positive infinity. So that's how you would graph that. And these are pretty much identical to what the test questions are going to look like for this section. And this is the only section for 9B. So if you understand this, you're going to be solid with a third of the test, is knowing how to graph these functions. We've got one more example and then we'll be done for notes. All right, last example. Equation over here on the right. We're going to figure out what all of these items mean. There's three things that we know about this. These are the moving numbers. Remember, anytime you see pluses or minuses, that means you're moving somewhere. So on this one, we are moving left and up. And the negative, just like with all of our other graphs, all year long, means we're going to flip it. Okay, flip it upside down. So looking at this, let's do our moving numbers, write down our asymptotes first. We've got to move left 1. And up 5. Okay, so let's put those as the asymptote equations. The x equation, the one that goes through the x-axis, is at -1, and the y is going through 5. Now the negative means it flips, so it's not in the upper right, lower left, it's in the opposite of that. So now we're looking here and here. Okay, so it's as simple as that. Don't have to worry about steepness, like I said. We're just putting the asymptotes on, putting your curves in the right corners, and then figuring out domain and range. So, domain, scanning left to right, this arrow right here is the furthest left point, and it's pointing forever to -infinity. So we've got -infinity all the way up to the asymptote, which stops at -1. It'll pick up again at -1 on the next curve and travel all the way over to the right to infinity. Range. By the way, the reason, and I hope you remember this, the reason that I'm using round here is because it's never going to touch -1. That's what an asymptote means. It's never going to actually be on -1, so that's why we have round parentheses there, and as always, we always have round ones when we use infinity. So the range is starting at -infinity, going up to the asymptote of 5, starting up again at 5, and going to infinity. Now, it may seem redundant that you have to write two things when you're going -infinity to 5 and 5 to infinity, but you're not. That's showing you that the graph is never going to touch 5. It's going to go up to 5, it's going to jump over the 5, and then keep going beyond that. So it's never going to actually touch that 5. That's why we have to write it in this fashion. So that's everything you need to know for this chunk of the test. Hopefully that makes sense and the homework is easy for you today.